Second type of word problem that we're talking about here is what I call a fencing problem or a fencing question. The fencing question is always about the area of the whatever the situation here is. So in this case, it's a rectangular construction site. So you're trying to find the area of this rectangular construction site. There are two kind of questions they can ask. One is they want you to maximize the area of this construction site. The second type of question is what is in this particular case where they actually give you the area and ask you to find the dimensions, right? But to set up the question is identical. The area is always a rectangle, and the area of a rectangle is always a length times width. There's no other tricks to it. The area of whatever they want to find is going to be a rectangle. It's going to be length times width. And then what's going to change for each of the questions is the following. The question must give you some sort of fencing material. So here it says 1,200 meters of fencing material. They also tell you in the question, how many sides do you need to construct? So here, I need one side here, one side here, and one side there because this is a wall. You don't need to put a fence on the wall. So you would have a W on this side, a W on this side, and an L on this side. So the perimeter is going to be L plus 2W, and the perimeter is going to equal to the amount of fencing material that's provided, which is 1,200 meters. So the length would equal 1,200 minus 2W. And you can substitute that right into here to set up your equation. So your equation is now going to equal to 1,200 minus 2W times W. Okay. Again, two types of questions. The first type is if they want to maximize it. I find that easier to do because then all you have to do is find a zero here. W equal to 0, W equal to 600. So to maximize the area, width would have to be halfway between the two zeros, which is 300 meters. And from that, you can calculate the length, which is 1,200 minus 600. So 600 times 300 would be the best case scenario. Now, that's one kind of question they can ask. This question, though, they gave us that area and asked you to solve for the value of W. So that's the other kind of question where you're not looking for the vertex. They actually give you the answer and you need to solve for the quadratic equation. So let's do that. So here they give you the area, which is 180,000. So 180,000, because that's the area. What's on the other side? Well, the other side is the length and the width. The width is W. The length, we already calculated, was 1,200 minus 2W. So what we need is we need to expand the bracket, 1,200W minus 2W square. Bring everything to one side. I like to keep the A value positive. I think it's always easier that way. It's all divisible by 2, so make the question slightly easier. I'm going to divide everything by 2. Okay. Now, this one is actually something that's factorable. Okay. It's a perfect square trinomial, something that we did earlier. So I'm going to do factoring here. But if you want to use quadratic formula, you feel free to do so. Okay. It's just I find factoring in this question is a little easier. W is going to be W squared. W squared is going to get me W. 900 is 300 squared is going to give you 900,000. Well, no, 90,000. Okay, so 300 square is 90,000. And this is A, this is B, this is exactly 2AB. So this is actually X minus 300 square. I can actually factor this into a perfect square trinomial, which means W must equal to 300. So to get 180,000 area, meter square of area, the width has to be 300 meter for this particular construction site. Therefore, the length is going to be 1200 minus 2 times 300, which is 1200 minus 600 equal 600. So the dimension for this construction site is 600 meters by 300 meters, and that would be the answer to this particular question. What dimensions enclose 180,000 meters square of land, 600 of length, 300 of width?